So continuing on, we were looking at some equations that we were graphing to see if they were linear relations or not. And we already did number 2, y equals x squared, and we saw that was a curve, a special type of curve called a parabola. And obviously it's not a linear relation because it doesn't form a line. Okay. Looking at the other ones, 1, 3, and 4, these are ones that you guys should know how to do. How do we graph this? You've got a bunch of choices. Yes, and then quadrants. And then, sorry? Okay, the y-intercept is, no, that's the slope too. Yeah, so remember, so you're using y equals mx plus b form, which is good. So the y-intercept is 2. So we plot 2 on the y-axis. The slope is -3, but we need to write it in rise over run form, so we need to write it as a fraction. So from the y-intercept, this tells us to rise -3, which means go down 3, and then run +1, which means go to the right 1. And there's our second point. And we get this. Okay. Is that linear? Yes, because it forms a line. So this would be linear. Any equation that has y and x in it, or y or x, are always linear, because we were graphing those earlier in the year and they were all lines. So if we look at number 3, y equals 4, how would we graph that one? How would we graph y equals 4? What's so special with a line that has just y in it? It's what? Yes, and somebody said it's horizontal. So yes. So it's a horizontal line through every point where y is equal to 4. So we pick a point where the y coordinate is 4, 0, 4 seems to be the easiest one. And then we draw a horizontal line through it. Is that linear? Yeah. And the final one, x equals 1. What kind of line is that? Vertical. If it has just an x in it, it's vertical, so it's a vertical line through every point where the x coordinate is 1. So all we have to do is find a point on the grid where x is 1, and we can do 1, 0, and then we draw a vertical line through it. Linear? Yeah. But is this a function? No, because you could draw a vertical line through every point on this line. So they're all so remember the difference. They're all linear, but this one specifically is not a function. Okay. So whenever you get an equation that has a y and x in it, or just a y, or just an x, they're always going to be linear. And we just showed that by graphing them. Okay. Let's look at a few problems. So this is going back to your knowledge in middle school. Do you remember how to find the percent of numbers? So we purchased a new car for $24,000. Every year, the value of the car decreases by 15%. Okay? That's something that's called depreciation. And whenever you purchase a car, as years go by, it goes down in value. How much it goes down depends on how many kilometers you drive, how well you take care of it. Has there been any accidents or anything like that? But in general, if you sort of maintain the car reasonably well, it'll go down by about 15%. Okay? So we want to see if this is a linear relation. Like every year, does it go down the same amount? As we increase by 1 year, does the value go down by the same amount? So what we want to do is we want to see, okay, what's the value of it at the end of year 1? Well, to find that, I have to take 15% of 24,000. That tells me how much it goes down, and then subtract that from 24,000. So I have to do 24,000 minus, and to calculate a percentage of a number, we change it to decimal. 15% is the same as 15 hundredths, which is 0.15, times the value. And that will give us the new value of the car after 1 year. So when we do that, I'm just going to cheat a little bit here. We get 20,400. So remember, we started with 24,000. How much did it go down by? $3,600. So if it's linear, then the next year it should go down by 3,600 again, and then by 3,600, and then by 3,600. Well, let's see if that actually happens. So the end of year 2, we take the value of the car now, which is 20,400, and subtract 15% of 20,400, or 0.15 times 20,400. That will give us the value of the car after 2 years. So when we calculate that, we get $17,340. You should be able to see that's not the same amount. In fact, it's actually goes down by $3,060, not $3,600. Which kind of makes sense because year after year, the car is worth less. So we're going to be taking 15% of less. So it's not going to go down as much. Okay? But this tells us right here that it's not linear. We can stop. We don't have to calculate anymore. For part B, maybe you can reason it out by just looking at it, by just reading the question. So for a service call, an electrician charges $75. So right away you have to pay $75 plus $50 for every hour he works. The total cost for the service is related to time. Would that be linear? Think of it. How much, as soon as he doesn't do any work, he steps in the door. How much? 75. Okay. Then he works for an hour. How much? So 125 total, right? Okay. Then he works for another hour. 175. What's it going up by every amount? Right. So for every hour he works, it goes up by 50. That's the very definition of a linear relation. Okay.
Can we work in the library? Thank you.
So for every hour worked, the cost goes up by $50. So the hours are increasing by 1 each time. The cost is increasing by 50 each time. That is the very definition of linear. And the final problem we're going to look at deals with rate of change, which we've already talked about. Remember, rate of change is the same as slope. It's calculated the same way. So we need 2 points, and then basically you're using the slope formula. But before that, what are the independent and dependent variables in each graph? What's the independent? Yeah, it's always the horizontal axis. And for both of them, it's time. And the dependent? Volume. But they're slightly different graphs in that the first one shows you what's happening when you fill up the tank, and it makes sense that the volume goes up as time goes on. And the second one shows you a graph of emptying a water tank. Okay? So as time goes on, the volume goes down. So we want to find the rate of change for each one. Well, you've got lots of points in each one you can choose from. So if we look at the first graph, graph A, I'm going to pick this point here because that's a really easy point, 0, 0. And then pick any other point you want. I mean, we could pick this one or this one or this one or this one. I'm going to go up here and say 120, comma 6,000. So to find the rate of change, I have to find the difference in the y's divided by the difference in the x's. So for A, the rate of change will be, and it doesn't matter which one you choose for the second and first x's, as long as you stay consistent in each one. So I'm going to go 6,000 minus 0, divide 120 minus 0. 6,000 minus 0, divide 120 minus 0. That gives us 6,000 over 120, which is 50. So that's the rate of change. What does it mean? You have to be able to describe what it means in terms of the problem.
Like, so linear, that's how much it drops out every.
Drops?
Like, it increases, right?
Yeah.
Increases by every, hour.
Right. So we would say the tank fills at 50 liters per hour. That would be describing. Okay. When you get a rate of change question, you will usually be asked to describe what your answer means. So for B, a rate of change, well, we've got different points because it's a different graph. So I'm just going to pick the ones on the axes. So this is 0, 6,000. And what's this point? 60, 0. Good. And then you just do second y minus first y over second x minus first x. Doesn't matter which one you choose as first and second. I'm going to say this one, so I'm going to go 0 minus 6,000 over 60 minus 0. 0 minus 6,000 over 60 minus 0. And that gives us negative 6,000 divide 60, which is negative 100. Which makes sense because when a line climbs, the slope is positive, but when it drops, it's negative. How would you describe this one? You got to be careful with your wording here. The tank, what would you put after that? Sorry? Empties at, how would you write it? Right. You don't put negative 100. Why? Because this word empties means negative. Okay? If you said the tank empties at negative 100, well, technically it's emptying at a negative rate, which means it's increasing. And you can see how confusing things get. Okay. Okay.